in the days of cloud computing, a lot of people ask, do you need storage solutions like you used to? What's the purpose of storage solutions and stuff like that? And let me just tell you, you definitely want to have your own storage system and your own storage solutions. There's more data now than there ever has been before, and having storage solutions on site at your office are going to be a huge business advantage to you. You don't want to rely on everything being in the cloud. You know, if you try to access the cloud anytime that the internet's down or you're having some kind of connectivity problem, there's going to be challenges. Of course, the cloud has made everything a lot easier, but there's absolutely no reason now with the newest storage technologies not to have that data available to you. And then, of course, you have things like video and photos and things that really just take up tons and tons of space. You want to be able to have that available to you. As we were talking about some of that stuff, I was thinking about some of the history of storage and how much storage has changed over the years. And it made me think about some of the old technologies and where things kind of began. And I was thinking about the way things started versus the way things are today. You know, you take it so much of it for granted. Today, if you weren't involved in the history and how things have evolved, you're really lucky. If you're just getting into like PowerStore today, the technology behind it is so advanced and so simple. It's nothing like it used to be. For example, you used to have to run to build up your speed and everything. You used to have to run what we called RAID arrays. So RAID, and I can't remember what that acronym stands for, but basically it was different types of protocols that were used to expand or combine multiple drives. Now, back in those days, what you had was two basic different types of interfaces that were commonly used on computers. There was the parallel ATA, which most people, myself included, knew as the IDE standard. And the IDE, and by the way, AT was the standard PC that IBM invented. They called it the AT standard. And then so ATA stood for AT attachment. So you'll see that pop up from time to time. Someone refer to AT or refer to ATA. ATA is just AT attachment. And then the old IDE format was called the parallel ATA. Later on, that became the serial ATA or SATA, which most people pronounced as SATA. So, but in the early days, you had the IDE interface. Now, back in those days, the thing that you have to remember is drives, hard drives, were all physical spinning platters. They were magnetic storage. They were, in a lot of ways, very similar to the floppy drives. Floppy drives you would put into the drive, it would spin up. It was a magnetic disk, and you had a little head reader that would come down, and it would read the data. It would look for the data, read the data, and then send it to the computer. Now, the advantage of the hard drive was it was attached and it was running all the time. So you couldn't hot swap. You couldn't like plug it in, pull it out like you could with the floppy drive, but you could have really large storage. And back then, large storage was like 500 megabytes, you know. So that was always one of the big, I guess, in the computer industry, the engineers and the designers, that was always one of their biggest hurdles, one of their biggest challenges was at the end of the day, all of this data was stored on this physical device, this thing that had platters that would spin. And that was really, really a challenge trying to, because the rest of the computer was all, electrical. So it was all semiconductors and it was all, switches, binary switches, memory, random access, and read-only memory. So everything was super quick. Again, that's by their standards back then. Still slow by our standards today, but there wasn't any problems with gathering the data in the memory. Memory was super fast, and even back in those days, we had all kinds of techniques for getting around how slow hard drives were, and of course, floppy drives were incredibly slow, and then other storage that came out later. So there was always kind of this problem with magnetic storage, which is what hard drives, floppy drives, all those, that's what they all are. They're magnetic storage. So what would happen is basically the computer would ask for some information and it would say, this information is, I need this information. And then there was a table of contents that the drive would look to. It would say, this information stored on this platter at this location. Then the reading head would go seek out that location on that platter and begin to read at that location. and then it would spit that information out. Now, all this stuff would happen pretty quickly, but by computer standards, that's forever. So there was a bunch of different types of technologies that were created to speed that up. Of course, the parallel ATA, that's the IDE interface, which was probably the slowest, but it was the most cost efficient and effective at the time. That was when personal computers were first really taking over and were really accessible. So there was a huge compromise between cost and speed back then, huge compromise, and usually cost won out because they were trying to reach mass markets. So then later on there became the interface called the Small Computer System Interface, SCSI, which most people pronounced as SCSI. So they would refer to a SCSI drive. So the SCSI drive was much, much faster. And what it gave the ability to do was to read a lot faster, but it also opened up a lot of RAID array options. So what was a RAID? A RAID was combining in different ways. Now later on there were ways to do this with IDEs and such, but mainly SCSI was super fast comparatively. Again, everything's comparatively super fast, and you were able to set up arrays with it. So a RAID would have basically three. There was different levels of RAID, but there were basically three concepts you would have. One version of the RAID would just expand. So if you had a 500 megabyte drive and another 500 megabyte drive, they would basically daisy chain together, and you would have a 1 gigabyte drive. So that was a big deal back then. The only problem with that is if one of those drives died, well, then you lost them both because they were linked together. So that's no good. The other one was called there was another type of RAID that was called the striping method, which again I referred to how slow things were back then. Well, it was also so slow to read and write that what they would use is they would alternate bits of data between the two drives. So you had two drives, and instead of writing everything to one drive and reading everything from one drive, you would read a little bit from this one, a little bit from this one, a little bit from this one. So it was effectively twice as fast as one drive. Again, drives back then were very slow. There was, you couldn't do video editing or things like that on a regular drive. So that was a technique that they used to actually enable things like video editing, photo editing, big data set type processing back then. And now again, the problem with that, one of those drives fails, and you just lost all the data. Later on, then they came out with there was another type of RAID that they would use that would just duplicate. So you'd write something here and you'd write something here. You'd write something to both drives, and if one drive failed, that's okay. You had the other one, so you were good to go. Now, of course, that meant that was twice as expensive. You had the redundancy, but it was slower, and it was costly. So then there was another version. Let's see. There were a handful of different versions of RAIDs, but this was I think there were 4 versions total, and then some other ones that were, kind of used out on the periphery of things. Then the other version would use 3 drives, and it would split the data between the two, and the third one would be used for redundancy. It's a mathematical thing. It works out when you think about it. So you had 3 drives. If one drive failed, it would slow the overall speed down, but all of the data was on the 2 drives. So it would use the third drive for speed, and then redundancy. So you had speed and redundancy if you had 3 drives. But if you lost 2 drives, then you were in trouble. So those are the kinds of techniques that were used back when we were still dealing with physical spinning platters. Now, what's happened in recent years is a lot of that has changed because we've started to move, and a lot of people still have physical hard drives that use spinning platters, traditional ones, but everything's changed to non-volatile memory. So what you might hear SSD drives or solid state drives. That's what we're talking about, non-volatile memory. That means all of the data is now electronic. Now, this is a big deal. This is a huge deal. And what makes it a big deal is because the hard drive was always the slowest part of a computer, because the computer was super fast, but it would always grind to a halt when I had to wait to that little seeking head to find that little area on the platter. Non-volatile memory has an entirely new connection called NVMe or NVM Express. And this is a replacement for SATA, SATA, which is the serial version of the ATA or the AT attachment. So SATA was replaced with NVMe, and it's a pure flash memory that goes directly into the motherboard and isn't translated over a cable or anything. So it's lightning fast, and it eliminates a lot of the needs for the RAID arrays that we were talking about earlier. So now on these new storage systems like PowerStore, the way that they do it is they just put in more memory and they divide the load amongst the memory. And you can hot swap them, you can add in different ones. If one goes bad, you can pop another one in and replace it. And just unbelievable the things that you can do with them. And that's where we're at today. And there's all kinds of cool technologies coming out there. And the storage solutions are just incredible compared to what they used to be. And you can have petabytes of storage, lightning quick, super redundant. You just put a rack in your server room and you've got petabytes that you can store everything to, and that's completely accessible from every computer in the system. Way more efficient than cloud storage. And then you can back all that stuff up off site very easily. And once you get into virtualization and some of the other techniques along in there, that makes it even more abstracted. And that abstraction can lead to all kinds of amazing features and sets of things that you can do. So really cool stuff.